Next, let us see the illustrate with examples the ML applications. The first is learning associations. So, if we take a market basket analysis, a person who goes to a market, he buys an item, okay, and it will initiate him to buy the next item. Suppose if he buys X, naturally he buys Y. For example, he buys a bread, he buys a jam. Similarly, one of the example I told in the previous video, if he buys a pencil, he buys a rubber. So this is, we call it as an association analysis. That is, a per customer who buys X will also buy Y. So here association rule is a conditional probability. That is, a person who buys X also buys Y. Buying Y condition on X. Usually when they buy jam for the bread, that is they buy jam if they have brought bread. Okay, this is called as point 0.7. Point 0.7 means is that even 70% of the customers have bought such associations. That is, if I buy the bread, they also buy jam. So what we call this one as a learning associations. This is one of the a very good application of an ML. So what they do is in the market basket analysis in the supermarkets, what they do is they take the history or the transaction done by all the customers, they study it, they analyze it. Okay, after analyzing, they come to know that 70% of the customers who bought bread, they also bought jam. So what they do is they try to keep such items in the same rack so that there is an increase in sale. So this is called as an association rule. Next is what classification. One more very important application is classifying. Consider an example of a credit score for loans. So when you apply a loan for a bank, they will sanction the loan. How they will sanction the loan? Based upon these two features, that is income and the savings. If the income is greater than some value and if the savings is greater than some value, then we say it as he is a low risk customer and we can sanction the loan. So there is a income is greater than like 50,000 or savings is greater than 1 lakh, then we can say low risk customer. Otherwise, high risk customer, the so loan cannot be sanctioned. Means all the customers are classified as low risk and as well as high risk. So you see all the values here, the positive values. So these are nothing but the customers. So if the income is around 60,000 and suppose you take this one as a 50,000 value, okay, income is greater than 50,000, so let me take this value as 60,000 and the savings as around 2 lakhs. So this is, let me take 1 lakh and this is, let me take 2 lakhs. So the value comes here, your marking comes here, and suppose here it is around income may be around 80,000, here income may be savings may be 2 lakhs, here you will get the value. Similarly you will get the value. So all these values above this marking, the income greater than 50,000 and the savings greater than 1 lakh, all these values which comes above this are what? Low risk customers. Others are what? High risk customers. We are classifying, we are bifurcating the two categories which are low risk and as well as which are high risk. Okay, one more application is what? Pattern recognition. Pattern recognition, that is recognizing the patterns. It is a process of recognizing the patterns using machine learning. For example, optical character recognition, OCR, handwriting recognition, face recognition, which may be very much important in the uh, different areas where illegal activities may happen. Next, medical diagnosis. It may also be helped in speech recognition, natural language processing. It may also help in biometrics, face, finger, iris, palm, signature, voice, keystroke. Okay, so all these it can be also helped in compression. So like this, in different areas, the machine learning can be applied. One more key term, let us see here: outlier detection. What is outlier detection? Outlier detection is finding the instances which doesn't obey the rule. Okay, so for example, here let me take the values. This is the data set. All these are 10, 20, 30, 40, 80, 90, 60, but this value is greater than 100. So it is outlier which doesn't obey. These values are all between 1 to 100, but only this value which is greater than 100. So we call it as an outlier which doesn't obey the rule. Let us see. These key terms we will be using in the next chapters. So the next is regression. A regression is nothing but fitting a function from an input domain into its output. So here means, let me take an example. This is an x and this is a y. X is an input, y is the output. Okay. So here car attributes which are brand, it may be year and mileage. Okay, so here x is, they have taken here is a mileage. If this is a mileage, this is the price of the car. If this is a mileage, this is the price of the car. I'll go on marking. So here let me take an example here. Let me take here. So here if this is a mileage and this is a price of the car. If the mileage is 10 kilometers, if the mileage is 20 kilometers, if the mileage is 30 kilometers, so if the mileage is suppose it may be 1 lakh. Okay, if the mileage is this one, it may be 2 lakhs. If the mileage is, it may be 3 lakhs. So what happens? I'm drawing like this. I'm drawing a line here. Okay, so what happens? As the number of kilometers increases, the mileage also, the price of the car may also be increasing. So here I'm drawing a model or a linear regression line. So next time if the mileage of the car, if it is giving 40 kilometers, then the price may be around like 5 lakhs or 4 lakhs. As mileage increases, the price is also, what is happening here, the price is also increasing. So the linear equation line I can draw and fit a model onto this data set. This is my data set, no? What is my data set? If it is 10 kilometers, the price is 1 lakh. If it is 20 kilometers, the price is 2 lakhs. Just I'm giving an example. If the price is 30 kilometers, it is 3 lakhs. If the price is 40 kilometers, 4 lakhs. So next, if the mileage is 50, just I can predict what is the price. Yes, I can predict it as 5 lakhs. If the mileage is 35, what I can predict it? The price may be about 3.5. If it is 35, I can predict it. Draw a line here. Write the value 1, 2, 3, 4, 5. So here it may be around, if you take it 35, you draw a line here. Approximately I'm writing it here. It is around 3 to 4, middle 3.5. So like this linear regression model we can develop in machine learning and predict the future. Predict the unknown value. So this is nothing but linear regression. So in the next video, I'll be sending about supervised learning.